My name is Katie Hughes, and this is my lab report for Physics 2211, section N07. For this lab, we were instructed to show something moving at a constant velocity. In order to do this, and according to Newton's second law, V final equals V initial plus F net divided by mass times delta T, the net force has to equal 0 to achieve constant velocity. Here is the original video of a water bottle rolling across a table pushed by myself. After recording the video, I uploaded it to Tracker to track its movement across the screen. As you can see here at the bottom, the video has been shortened to only track the movement of the ball while it has constant velocity. The axis of the bottle, is in the positive x direction. After shortening the time interval, the center of the mass of the bottle was tracked across the screen to record the coordinates of the bottle. Here we can see the bottle moving in Tracker as the center of mass is recorded across the screen. And here we can see the graph of the data that was collected. In order to construct a model of the graph of Newton's second law with a net force of 0, I used VPython software. Based on the data recorded in Tracker, I was able to find the ball's initial position, which is shown here, and average velocity, which is shown here. The ball was tracked until time equals 1.249, which is shown here. To use the actual equation of Newton's second law, I had to write it into the code at this point. V final equals V initial plus F net divided by mass times delta T, and position final equals position initial plus average velocity times delta T. It is also important to note that the net force is equal to 0 in order to achieve constant velocity. After making all these changes to the code, I ran it and got this graph, which is the model graph for the experiment. Here we can see how the graph of an object moving with a constant velocity should look. Now, here is the model graph versus the experimental graph as functions of position and time. The experimental graph is in blue and the model graph is in red. As you can see, while similar, these graphs are not the same. The experimental graph is not perfect due to some errors in the experiment. The main cause for error in this experiment is the fact that the water bottle in the video is not moving at a constant velocity throughout the whole video. The water bottle is not moving at a constant velocity due to the initial push to make the bottle move, giving the bottle a net force that is not equal to 0. To correct this error, the video could have been cut shorter. Another cause for error is the fact that the tracking of the center of the mass of the bottle within Tracker is not measured, but only judged by hand. This would have a minor impact on the graph of the ball. Additional questions that need to be addressed include these two. What would change or remain the same if the axis were flipped? Should the axis be flipped, the graph of the slope would be in the negative direction rather than the positive direction. Ideally, all of the other data would be the same. What pushes and pulls give the bottle a net force of 0? The initial push of the bottle overcame the air resistance, but was then countered by the friction of the water bottle against the table. The force of the initial push and the force of the friction of the table during the time interval shown in Tracker canceled out to make the net force equal 0.